Great. Hi. I'll just get this up. Can you see that?
Yes.
Yes,
Yeah.
good, great. So, hi everyone, I'm Matt Sinton-Hewitt. I'm a software developer at OVO Energy. If you haven't heard of OVO, we are an energy retailer based, our main office in Bristol, but other offices in London and Edinburgh and many more actually, growing all the time. If you think of the energy industry, you probably wouldn't think of tech straight away, but OVO are changing this, I'd say, in a similar way to how Monzo have with the banking industry. In the picture, you can see me and my two sons, who bring me much joy, sometimes too much, especially these days. I'd also like to just give at this point a special mention to my wife and thanks for her support as I prepared this talk, and to my line manager, Simon Burrell, and for my friends and colleagues who've encouraged me. I've been known at work as a serial dad joke offender. I kind of think that's okay. I think it's important, especially in these times. For me, working in the same environment as two children can be a bit tricky. So, for example, the other day I went to make myself a cup of tea, you know, as you do, but I stepped on something. So I looked down and I saw 3/4 of a yo-yo. Why, oh, why? I'm assuming there's loud, just amazing laughter going on there from everyone. So I'm just going to continue. So I'm going to talk to you about Scala 3. I hasten to add, this is just kind of all coming from me. I don't represent a body of people. I don't work on Scala 3. It's just my research into it, and looking forward to what it will bring. I have been working with Scala for about 2 years, and first started experimenting in 2011. That's on Scala, by the way. So I'm aiming to give you a picture about Scala, even for the people who don't know anything about it. And so first, I'm going to take a step back and just ask, what is Scala? So it's completely interoperable with Java. It's a strongly typed language on the JVM. So it translates to Java bytecode. Scala is very versatile. You can actually use it as a scripting language. And they don't need to be compiled. There's a very impressive tool called Ammonite that can essentially turn your, become a new terminal for you, but a Scala terminal with all the type-safe goodness that you get. You can use Scala for backend and front-end development. So there's a Scala JS ecosystem. Like everything else, Scala can transpile to JS. Yeah, so there's more to it than might meet the eye. I'd say, in particular, Scala just distinguishes itself from other languages by being especially type-safe and correct, while also concise. Some might say the initial efforts were in some way to defeat the boilerplate problem of Java. And you get that from type inference. You don't need to specify types all the time, despite being a strongly typed language. So moving swiftly on. Hang on, I missed a bit. So it's functional and object oriented, and that might have caught your eye, and you may be thinking, what? Is that even possible? So yes, I'm not going to like dive into this, but I just thought I'd mention that OO and functional programming are actually orthogonal concepts. OO is about encapsulation, polymorphism, and abstraction. But functional programming doesn't really take an opinion on those things. You can use functional programming in whatever kind of structure you want, and polymorphism is something that plays a role, but it's not required. So I'm going to take you through very briefly some Scala history. It was created, well, invented maybe in 2001 by Martin Odersky, officially released in 2004. To give you some context, 2004 was when Gmail began. And Scala 2 was 2006, and now Scala 3, we're hoping is going to be by the end of 2020, this year. Who knows, we'll have to wait and see. Earlier reports I saw were kind of stating it to be for autumn this year, but I haven't heard anything more towards that end. I think it's more likely to be the end of the 2020 now. So what is the purpose of Scala 3? What's it all about? It's actually, so I think most importantly to note, it's not a revolution. It's going to be an evolution of Scala 2. It's not going to go down the same tracks as Python 3, which some of you may know about, and the sort of great difficulties the community's had in migration there. It's going to hopefully be a lot smoother. The other thing is they've taken patterns that they've taken stock of the patterns that people tend to use with Scala and become more opinionated and embracing those patterns. Also simplification. So simplification is in two ways. They're going to simplify the language itself, so simplify it for the language developers so that they can create new features more easily, and also for end users. Lastly, there's consistency. So that's mainly to do with the type system. I'm not going to talk too much about that, but the other thing I'm just going to mention now at this point is that the whole language has a completely new compiler, which is called Dotty, which is called that because DOT stands for dependent object types, which I don't know much about, but it's the paper that it's all based on. So we're going to go through, we're going to get into the meat of it now. We've got kind of 4 areas to look at. The warts that have been removed, the dropped features, the new features, and migration. Okay, so here's our first wart. So I think what I quite like about Scala, the people behind Scala, is that they seem to be quite open and honest, and they've openly said, you know, these are some issues we have with Scala 2, and we want to fix them. So at the top here, we use the keyword def to create a method, and then next we create a function by converting that method to a function. Now, the distinction between a method and a function is really not something that most developers should need to care about. So it's quite frustrating, especially for newcomers to language, to suddenly come across this problem where you have to kind of add this underscore. Coming from like a functional perspective, you want to be able to just pass functions around like values. And this awkwardness can be a problem sometimes. But in Scala 3, they fixed that. It's no longer a problem. Next thing I'm going to mention is the package object. So what happened here really is there's kind of an arbitrary restriction that you have to define things inside either a trait, object, or class. And there's no real need for that. And to kind of get around that, they created the package object, which allows you to put something inside an object, but it appears as if it's just part of the package. So that's just like another kind of small wart. I think the accumulation of these things that they're fixing is really good. So now you can just define your friend Dory at the top level, and you can define anything really, wherever you want to. So here's some more examples of a method add a person and an instance of that person, our friend the Bob. So dropped features. So there's not too many dropped features. XML literals is one of them. I think it's the biggest thing. Well, there might be one more that I'll get onto in a minute. It's not, so the reason they're dropping it is to simplify the language, and because it's not really used enough for it to be to carry its weight. So in Scala 2, you can define, this shows at the top, you can define XML, and you can just define that in your code. In Scala 3, you won't be able to do that. You'll have to use a library and do some XML interpolation, string interpolation. So that you kind of have to ignore the syntax highlighting there. It's a bit weird. I'm sure it wouldn't look like that. But yeah, that's how that's going to be. But for most people, I don't think it's a big deal. Most people aren't using this. Next, we got some new features. Yay. So intersection and union types. I'm writing some TypeScript these days, and often creating intersection and union types. It just seems like a simple, natural way to combine types. It's might take a little bit of getting used to if you haven't done it before, but you can see with an intersection, really it's the same thing as an and, is how I see it. So we take two types. We've got a has age trait and a named trait. So they both have you have an age and a name, and I want to do something where I require a type that has an age and a name. So I can just use my and to say, this is my type that I want. So you can kind of ad hoc require and compose the types that you want. Then there's union, which is like an or. So you can see at the top there, either string or int. So we've just got some condition, if a condition, we're going to string or a 0. And then another example, we've got man, woman, or child. So you can have a union of, I don't know, arbitrarily many things, perhaps. One thing that I have found, though, is that you can't just, even if both your man, woman, and child, if they can all eat toast, you can't just say my man, woman, or child dot eat toast. You need to match and one by one for each case do what you want to do. So that's just something to be aware of. If you wanted to do something where you can just do dot eat toast, then you're probably not using the right construct there to do that. Yeah, and what I would say as well is that you can already effectively get the same behavior as both of these things in Scala by composing types using the keyword with or using either, but it's subtly different, and yeah, we'll see. I think it's pretty good though. I think it's more easy and natural. So enums, simple enumerations. So in Scala 2, there is a type. There is such a thing called the enumeration for creating enums, but it's really problematic to the point that nobody uses it. Instead, we kind of roll our own sealed trait hierarchies, or rely on a library like enumeratum that gives us this sort of nice enum behavior. But then you're getting something quite simple through either a third-party library, and it becomes a lot more complex than it needs to be. So it's really great to see. This is definitely one of the big features coming in, that we can define enums really simply and easily like this. Under the hood, for you Scala guys, it's interesting to note that it is actually working in the same way as the kind of sealed trait hierarchies that you're used to. So yeah, the other thing is you can actually do quite cool stuff. It goes beyond simple enums like this. So you can define algebraic data types. So here we have the option type. So it's parameterized on some type T. So that could be an int or a string or anything you like. And we've got 2 cases there for it. And you can go further than that. This is an example of a generalized algebraic data type. And it is such because that type T that it's parameterized on is extended. So extended, you can see extends tree boolean, extends tree int. And so this would kind of be like a mini language that you can create quite easily, that you could then build together some kind of logic program and then run an interpreter over that logic. So it's pretty neat. Right, here's the next one, new feature, extension methods. We can add methods to a type after it's been defined. I've got my case class person, so I've got some person, and then later, could be in a different bit of code entirely, I can give my person a description method. And we do this in this with the syntax that looks a little bit strange at first, maybe, but it kind of makes sense. So normally you define a method with your method name first, after the parameter, after the keyword def, then your description name, then your parameters. But in here, the first parameter, and it has to be a single parameter, is the thing you want to extend. So extending person with a method description. And then we can use that, create a Bob and Bob description. There we go. Slightly more complicated example. We've got now some text being passed in to our extended method. So we can now say that Bob is addicted to cat pictures. Yeah, so I think it's just quite useful. And it's really, the syntax is quite tidy and easy to use. So implicits, let's go back a step. Implicits are also known as term inference. Implicits are a really powerful mechanic that can be used to achieve all manner of things. In a nutshell, I describe them as a mechanism for passing values around without explicitly doing so. I got a little example to illustrate this. Bear with me. It's like whenever we used to play pool in the office, we had a rule that we'd play, where you have to put the black in the opposite pocket to your last ball. We only play this rule when the guy who told us, Juanfi, was around. He gave us the rule, and if he was there, we didn't have to say anything. We just knew we needed to play the rule. That's what we did. And so it's a bit like that. He provided an implicit, and we, as a pool function, required an implicit of some rules, and so we'd use those rules. Forgive me for that. I'm not going to go too deep down this because it's quite a big subject. So there's loads of nice changes, though, that are coming to address the current issues with implicits. I'm going to rattle through like 5 issues that there are, just to give you a flavor of this. So the first issue, being very powerful, implicits are easily overused and misused. There's an over-reliance on implicit imports can lead to inscrutable type errors. The keyword implicit is used for a large number of language constructs, requiring the reader to decipher what the intent is in each case. And implicit parameters are awkward. They must have a name, even though in many cases that name's never referenced. And they pose a challenge for tooling, because the tooling needs to, your IDEs need to know the whole context in order to give you the right completions and take that implicit scope into account. So Scala 3 is addressing pretty much all of these issues. I think maybe is all of them. But I'm just going to touch on kind of the core things. So given and using are our two new keywords. Given is a way to declare an implicit. So that's like Huanfi being the rule. So here we have an ordering for integers. So we know how to order integers. And then we have a method where you can see the keyword using. So we're using that ordering. Just give you a moment to see that. Then if we have that implicit in scope, if we've got that given, then we can just say max 2, 3, and that will return 3. So if you can see what's going on there. So in the past, that would have, both those keywords would have just been the keyword implicit. So now it makes it clearer what's actually going on. And that's the sorts of changes that are coming with implicits. Okay, we're almost there, don't worry. So I've got, this is both a kind of a dropped feature and also a new feature. So this is one of the biggest changes in a way, because macros are, the Scala 2 macros are not going to be supported. They need to be rewritten for Scala 3. And that's because those macros were dependent. They were working on the internals of the compiler, and we've got a brand new compiler, so they're just not going to work. They couldn't make that work. But that's a really good thing actually, because these macros in Scala 2 are actually experimental. They're in an experimental status for their entire life, and that's about to change. So now in Scala 3, macros are a proper thing. They've got an API. They're more principled, safer, and not compiler dependent. I don't have time to talk about tasty. It's a kind of structure that has no loss and it represents Scala files. But the macros are going to be based on tasty. So it means if Scala 4 was to come along, macros would no longer be a breaking change if they could still rely on this sort of intermediate format. So that's what I'm going to say on macros. And we're on to the last bit. Take a deep breath. We're all right. So migration. Migration, I really think, is going to be pretty smooth on the whole. It's not going to be trivial for everyone, but I think for your everyday user, it's going to be pretty smooth. They've done some impressive stuff. What I've seen is that because of Tasty, which I mentioned, you're actually going to be able to have Scala 3 libraries that you can use in Scala 2.13 code. And you can use Scala 2.13 libraries in Scala 3 code. So they're going to phase things out. So in Scala 3.1 is probably when things are the deprecations will be dropped, will start to get dropped. So it will be a pretty smooth migration process. And for the smaller changes, the sort of syntax changes, you can use the Dotty compiler to rewrite your code for you in a simple command. But the main problem is going to be macros will need to be rewritten. But for some very popular libraries like Shapeless, I think that's already been done. So there's some promise. So in conclusion, Scala 3 is not a new language. Macros are the most significant challenge to migration, in my opinion. Scala 2 will be supported for a long time to come, and Scala 3 will be tasty. So we made it to the end of my talk. Thank you very much.
Could everyone, I can't seem to unmute all for some reason. Normally I can. Could everyone unmute themselves and give them a round of applause?
I can do that.
Thanks.